In this video, we finally made it to past papers after covering all the material you need to know. So I'm not gonna say a lot about this, let's jump in. This is the past paper from May 2024, and I find most of my past papers from the site Paperlords. I'm gonna provide a link in the description, and you can also get them from the Edexcel website, I think. But anyway, so let's start. Before we start, you have 1 hour and 45 minutes, guys, for these tests. I suggest you solve as many past papers as possible before you take the exam, and try to time yourselves when you do it, and try to solve something on your own before you look into the solutions. So let's start with section A, and there are two sections in these tests. Section A consists of 10 multiple choice questions, 1 mark each. And section B consists of, I believe, 7 to 10, 11 questions, something like that, that give you anything from 1 mark to more marks. I don't remember. For example, a question of 10 marks is more difficult than a question of 1, and so on and so forth. Anyway, let's start with question 1. Which of the following is an SI base unit? So base units cannot be decomposed into other units. So the only answer that makes sense here is A, ampere, because the base unit for actually current is a base unit that you use to build other units. Coulomb is a derived unit because you have current is charge per second, for example. So charge is in coulombs, time is in seconds, and this is equal to ampere. So 1 coulomb is 1 ampere times seconds, so it's not a base unit. Same for joules. Energy is measured in units of kilograms for mass, and meters per second squared for velocity squared, so that's also not a base unit, and so on and so forth. Now let's move to question 2. A moving particle P decays. After the decay, there are 2 particles, particle Q and particle R. The diagram shows the momentum of particle Q and the momentum of particle R. Which of the following is a correct vector diagram showing the momentum of particle P before the decay? So pretty much in this case, if we add the momentum of particle Q that is given to us, it points that way, and the momentum of particle R, we have to find the initial momentum of particle P. So how do you add these vectors? You add tail to head, right? So vector Q plus vector R gives you vector P. So the only answer that makes sense is D, okay? Because momentum before, which is P, should equal the momentum after, vector-wise, okay? Because this is a two-dimensional momentum problem. So the answer is D. Now let's move to question number 3. So questions number 3 and 4 refer to the information below. A current carrying wire is placed between the 2 magnets as shown. So pretty much it tells us that the wire has a current I that points inwards, okay? Remember that if we have this symbol, it symbolizes the tail of the arrow. So this symbolizes a quantity. It's usually the magnetic field, but here they use current. It's a quantity that goes into the page, so we see the tail of the arrow. But if the symbol is that, with a dot, with a dot coming out, it means that we see the head of the arrow. So that means that if this was the direction, then the quantity is coming out of the page pointing at our eyes. So that's the information. We have the north and the south pole, etc. The current in the wire is into the page, so it's mentioned. Which diagram shows the direction of the force on the wire due to the magnetic field? So we have to use Fleming left-hand rule. So our index finger points in the direction of the magnetic field, which goes from north to south. Okay, so that's our index finger. Our thumb should point in the direction of the current. So our thumb should point into the page. Okay, therefore our middle finger will show the direction of the force, which is up, so it's C. Okay, hope this makes sense because you cannot see my fingers in this video. Okay, so again, index, thumb, and if you put your fingers of the left hand in this direction, in this fashion, you're gonna see that your middle finger points up. Okay. Now, question 4. When the magnetic flux density is 0.024 teslas, the force on the wire is 4.8 times 10 to the negative 4 newtons. The length of the wire in the field is 0.01 meters. Which of the following gives the current in amps in the wire? So here is where we use F BIL. The force is equal to the magnetic flux density times the current times L. What we have to calculate, we have to find the current. So I is equal to the force over B times L. Force is 4.8 times 10 to the negative 4. It's in newtons, so we don't have to convert. B is given in Tesla, so we don't have to convert either, 0.024. And the length is 0.01 meters. So we just read off that the answer is C. Okay. Now, question 5. Cyclotrons use electric fields and magnetic fields to give particles very high energy. Which of the following statements is true for charged particles in cyclotrons? The particles are accelerated by electric fields and magnetic fields. This is a true statement because particles are accelerated by the electric field in the sense that the velocity of the particles is increased. But they are also accelerated by magnetic fields in the sense that magnetic fields do not increase the velocity of charged particles, but they change the direction of movement for charged particles. And a change in direction is and a change in direction in the velocity of a particle corresponds to acceleration. So so statement A is true. And that's the answer, but let's read off the other statements. The particles follow circular paths of constant radius. That's not necessarily true because the radius depends on the charge and the mass and so on. The electric field changes direction when the particles are in the gap between the Ds. That sounds true. So let me think what's false here. The electric field changes direction when the particles are in the gap between the Ds. No, that's not true. The direction changes only when the moment they enter the Ds, not when they are in the Ds. Okay. The magnetic field changes direction when the particles are in the gap between the Ds. That's not true because there is no magnetic field there. It's only in the Ds. So A is the correct answer. Hope this makes sense. Now let's move on to question number 6. A capacitor of capacitance C is charged to a potential difference of V0. The capacitor then discharges through a resistor of resistance R. After time t, the potential difference across the capacitor is V. Which of the following gives the time constant for this circuit? So you have to do a little bit of algebra here. So V is V0. E to the minus t over tau. And by the way, I haven't mentioned that in the back of your paper, I'm not going to scroll because it's going to make you dizzy. They give you these formulas actually, so you can take advantage of that. Anyway, so if we do V over V0 equal to 1 over e to the t over the time constant and solve for e to the t over time constant, which is equal to V0 over V. And then if we take the ln of both sides, ln of e gives you 1, so I'm just going to write down t over tau is ln of v0 over v. So tau is t over ln of v0 over v. So the correct answer is D. They want to confuse you here because you can flip the denominator and get the minus sign, so minus ln of v over v0. Okay, the property of logarithms. If you have ln of x, that's equal to minus ln of 1 over x. Okay, now let's go to question 7. In the early 1900s, scientists carried out alpha particle scattering experiments. Which of the following statements is not a valid conclusion from their observations? So let's go read the statements. Most of the atom is empty space. That's true. the nucleus is made of neutrons and protons. It is made of neutrons and protons, but that's tricky because remember in the alpha scattering experiment, the original one by Rutherford and his students, they actually didn't know about the existence of neutrons, so that's a suspicious statement. So let's put dash there. Statement C, there is a concentration of charge in the atom. This is what they concluded actually. And D, there is a concentration of mass in the atom, which is also something they concluded. So the correct answer is B, because the neutrons were discovered later. We mentioned this in the video where we talk about Rutherford's scattering. So let's move on to question number 8. A ball collides with a wall and moves off in the opposite direction. So we have a ball, hits the wall here, and moves in the opposite direction. So the force time graph for the collision is shown. Which of the following is given by the area under the graph? And even if you don't know physics, you can take the, as I call it, the lawyer's route to finding the answer, which is using reasoning. So the area is going to be the area of a triangle. We don't care about that. We only care about units. It's certainly going to be some combination of force times time, right? What is force measured by? Newtons. What is time measured by? Seconds. What is newtons times seconds? That's joules. So the correct answer is then, wait a second, did I mess up something? Sorry, newtons times seconds is not joules. I'm sorry, I take the back, so I make mistakes. Force times time, so it's kilograms times meters per second square for this one, Newton times seconds. So we find kilograms times mass times seconds, so that's mass times velocity. So the correct answer is C. The change in momentum, mass times velocity, is momentum. Okay, so the answer is C. I'm sorry for the confusion. Now let's go to questions 9 and 10. Another example where they combine two questions. So question 9, a proton moving in a straight, questions 9 and 10 refer to the information below. A proton moving in a straight line with a speed v enters a magnetic field. The magnetic field is perpendicular to the direction of motion of the proton. The proton follows a circular path of radius r in the magnetic field. Question 9, the path of the proton then decreases in radius. Which of the following is a reason why the radius decreases? So let's try to draw a diagram. So you have a proton traveling with in a straight line with speed v and enters a region where there's a magnetic field, which is perpendicular to the direction of motion. So it's either into the page or out of the page. So this guy enters and loses energy pretty much. So the radius decreases because it loses energy. I gave it off, I guess. So the answer is A. The kinetic energy of the particle decreases. Now, question 10. An alpha particle also moving in a straight line with the same speed v enters the same magnetic field. The alpha particle follows a circular path in the magnetic field. Which of the following is the initial radius of the path? For this one, we have to do some math. So for the proton, let's go find the radius. We have Q times V times B being the force that the proton experiences when it enters this magnetic field, right? And this force should be the centripetal force because it undergoes circular motion where the velocity is tangent to the path pretty much, okay? So that's equal to mv squared over the radius, okay? So this velocity cancels, and therefore the radius, we find it to be m times v over q times b. Now the alpha particle consists of 2 protons and 2 neutrons, so it has 4 times the mass of the proton and 2 times the charge because we have 2 protons. So we have, for the alpha particle, we have 2 times q. Maybe I should write it with red. So we have 2 times the charge, same velocity, same magnetic field, and 4 times the mass, right? because we have 2 protons and 2 neutrons. So that's going to be mv squared over r. This v cancels. If we solve for r, we can cancel these 2. So if we solve for the radius, we find 2 times m times v. So let's call this r prime because it's that of the alpha particle. So it's 2 times mv over q times b, which is 2 times r. So the correct answer is B. And I'm going to stop here and continue with section B in the next video.